G is very important term, GME upon R square, right? This is very important term. This is called acceleration due to gravity, right? So this is going to be a active role in this gravitation. So let's discuss how it affects when we take the object on the surface of the earth. We are already on the surface of earth, right? If we take the object above the height, from the surface of earth to certain height, taken to the ground under the depth due to shape and due to rotation of the motion. So it's affected, this term is going to be affected. I draw something here. This earth, this is the earth. And if I go somewhere about the 300 kilometer away from the surface of earth, she is facing or he is facing some kind of weightlessness. Now I am going to solve this by this phenomena is going to be occur. Actually, the main key role of this is effect is force due to gravity. This is the fact. This is the reason why we are feeling the force. This is the reason why we are attracting towards the earth. This is called the acceleration due to gravity. That's why we are going attracted or feeling some gravity, feeling some acceleration towards the earth. Okay. So effect of G. Effect of G due to some cases, due to reasons, there are going to be discussed. There I am going to discuss 4 reasons. First one, due to height. Secondly, due to depth. Third, due to shape of earth. And fourth one, due to rotation of the earth. Okay. So let's start. First point, effect of acceleration due to gravity if I take the object at a certain height. So start. So students, what is going to be affected to the acceleration due to gravity if I take the object at certain distance from the surface of the earth? Let's discuss. Okay. This is the earth. Okay. And this is center of earth. I'm writing O. And this is radius of earth RE. And here is the object. Like this. Point object. Right. If I took this object to a certain distance above the height from the surface of earth, like this height h. Okay, this is RE, this become RE plus h. Earth mass is ME and object mass is smaller. Okay. This is initial state, I am representing as I, and this is final state F. Okay. So considering the initial state, okay, considering the initial state, so acceleration due to gravity on the surface of earth, it's placing on the surface of earth. G is equal to G mass of earth upon R square, and this R is equal to radius of the earth. R is the square. This is first. Okay. This is our initial state. I am writing as G. Okay. Then after that, final state. I took this object to a certain height above the surface of earth, that is h. Then this distance becomes distance between earth center and object is taken to be final state. R is equal to RE plus h. Okay, final state. Initially is R is equal to RE. So finally G is equal to G ME upon RE plus h ka square. Right? This is second. I am writing this as G prime for the distinction. Then divide second by first. We are going to calculate G prime upon G is equal to Gm upon Re plus H का square upon Gm upon Re का square. Dividing this by this, okay? These two terms are going to be cut. We are left over with Re square upon Re plus H का square. Noticing on this point, here I am going to taking out common Re from the denominator. Re square upon Re square 1 plus H by Re का whole square. Cutting these two terms, okay, G prime upon G is equal to 1 upon 1 plus H by Re का whole square. Taking this term above, 1 plus H by Re, this cut minus 2. Now, expanding this term with binomial expansion, okay, binomial expansion, we know that 1 plus x की power minus n, expanding up to two terms, 1 minus nx and up to so on. Okay, so I am writing here 1 minus 2h upon r. Clear up to this? Then we are getting G prime upon G is equal to G prime is equal to G 1 minus 2h upon R E. Okay, this is very important formula used to be asked in the exam. Okay, this is the effect. Now, how to study this effect? Write down this formula, then I am going to discuss. Now I get this formula, G prime is equal to G 1 minus 2h upon R, right? Now look at this, G prime is equal to G minus 2hg upon R. This is our term, main term. G is the acceleration due to gravity on the surface of Earth. Some term is subtracting from this, means to say the attraction is going to be reduced, is going to be some reduction in this value as we go up with certain height. Did you get my point? As on the surface is 9.8 and subtracting some term from 9.8, its term means acceleration due to gravity is decreasing with height. Decreasing with height. As a man or person or any object is going upward, the force of gravity, the acceleration is just force of gravity, right? We are writing the F is equal to mg. If this term is reducing, force is getting reduction, that is weight is getting reduced. We feel that our weight with height is getting lesser. So where we feel weightlessness. Here, where we feel the weightlessness. Weightlessness means this is a state of a person where he or she will feel that he does not have any weight. Just a feel, okay? So where it feels, see this, G prime is equal to G 1 minus 2h by R. Means to say this term, this source of attraction is going to be 0. Where? 1 minus 2h upon R, this term is not going to be 0, this term is also not going to be 0, this term should be 0. 1 minus 2h upon R is equal to 0, then 1 is equal to 2h upon R. We have to calculate at what height the weightlessness state will be going to become. Okay, so h is equal to R by 2. H is equal to R by 2, where R is equal to 6400 kilometer, radius of Earth is 6400 kilometer. Then height is equal to 3200 kilometer. Means to say at the distance 3200 kilometer above the surface of the earth, we will feel the condition of weightlessness. Very important formula. This is a very important formula. Okay, and also this. So that's why I draw this. Earth 30 kilometer. Here the she or he will feel the weightlessness condition. So this is the one article. In the next we will discuss what will happen with the depth and another sources. Thank you.